Hello everyone, my name is R. Ravin. I'm from Mallareddy Institute of Engineering and Technology. The session about mini project title is Detection and Classification of Cerebral Hemorrhage under the guidance M. Supriya. Abstract. Patients having an injury are susceptible to internal bleeding in the brain, which is very dangerous. Computer aided diagnosis system CAD, as their name suggests, use computers to help doctors reach a fast and accurate diagnosis. Our aim is to solve the issues of hemorrhages in the brain, especially when the symptoms are accurate like headaches or loss of consciousness. Using deep learning conventional neural networks, we intend to accurate a model that not only do the basic analysis and detect whether a cerebral hemorrhage exists or not in computed topology, scan images of the brain, but also detect the type of the hemorrhage. The process of detecting and identifying hemorrhage consists of several stages, include image preprocessing, image segmentation, feature extraction, and classification. Existing system employ traditional deep learning techniques, Seaman clustering, and image thresholding. Problem statement: to develop a CNN model to detect and classify the cerebral hemorrhage and classify accordingly using image preprocessing. Proposed system: data collection is a systematic process which involves accumulating and storing information. Data gathering is a first and important step that can influence our model. After data collection, we should pre-process our CT scan images. Image pre-processing includes importing the image, then analyze and manipulating the image in order to get an altered image as output. Segmentation of image is done after pre-processing. In each image, we need to identify and separate the hemorrhage part from the remaining part of the skull. Since we can't do manually that, we need to automatic and data driven method to these two relatively homogeneous things. Literature survey. According to literature survey in 2019, the author Idong Jong, he was implement the proposed methods, but there is a drawbacks. It is the detection of microbleeding but not hemorrhage. Software requirements: pandas, numpy, and other Python libraries. Google Colab for computing the deep learning algorithms. Hardware requirements: RAM 8 GB, processor Pentium, Core i5 and above. System architecture. In this system architecture, we have dataset. Take the image from dataset and image processing of CT scan. Segmentation based on the images. Feature extraction. The feature extraction doing raw data into a manual data. Feeding the vector of features into the model. Training the model. Classification based on grouping of similar items together. Testing dataset. Display the result, and end. In this project, we are using UML diagrams. First one, use case diagram. We having dataset, algorithm, and admin. Dataset retrieve the CT scan images, and algorithm pre-processing the CT scan images detecting the ROI, performing the enhancement, performing the segmentation, select of features and classify. The admin give the result of the images. And the second UML diagram is class diagram. In this we have three classes: dataset, algorithm and admin. And third one is sequence diagram. In this sequence diagram we have having dataset, algorithm, admin. Dataset give the retrieve CT scan images, performing the pre-processing, obtaining the ROI, performance ROI enhancement, performing the segmentation, selection of features, classify the types, store the result. The fourth one is activity diagram. In these sessions we having dataset, algorithm and admin. Modules. We are using three modules. First one is pre-processing, feature extraction and selection, model selection. Pre-processing. Pre-processing is the initial step of the method that involves the removal of high intensity pixel part of the image, such as that skull part, and removal of noisy. Feature selection and extraction. The feature extraction stage follow the segmentation process, which is the primary aspect in grouping segments with the similar characteristics together and eventually feeding into a CNN architecture. In image segmentation, an image-based CNN employed. To improve the accuracy, feature extraction techniques are employed. Model selection. The choice of the model is important. We use neural network algorithm to obtain the best results. Input. In this input we can take in from the dataset. Based on the input, we use the test cases. Test case ID, test case name, expected result, actual result and status. Results. Based on the input and the test results, it will give the result. Accuracy of test is 84.47%, loss 0.27. References. These are the references from this detection and classification of cerebral hemorrhage. Thank you.